Okay, so in the last video we talked about converting between degrees and radians, and in the video before that we defined degrees and radians, things like that. So now we're ready to talk about more definitions related to angle measurements. So a right angle, which you might remember from geometry or some other class, is 90 degrees, or pi over 2 radians. And remember, for radians you could say rad or radian, or you could just drop the notation altogether. So we'll just drop the notation altogether as long as it's clear from the context. So 90 degrees or pi over 2 radians. And what would something like that look like? So let's draw one in standard position, because it's good to get used to that. So x-axis, y-axis, we'll put an angle standard position here. Okay, so that means vertex at the origin, initial side is the positive x-axis, so a 90 degree angle or pi over 2 radian angle would be like that. Let's zoom in on that. I guess it's kind of hard to see the blue over the black, but and right angles are usually denoted with that little box right there, so that usually denotes a right angle. Okay. So that's an example of a right angle. Okay, now a straight angle, you may already know this or you may have guessed, is 180 degrees or pi radians, right? So remember, that's pi radians. We saw both of these conversions in the last two videos. So 180 degrees is the same as pi radians. So let's draw what that looks like. Let's use a different color here. So x-axis, y-axis. So we'll draw this in standard position again. So vertex at the origin, positive x-axis is the initial side. So for a straight angle, 180 degrees is going to be all the way around like this. Okay. So that's a straight angle, because it's just the angle is really like a straight line, right? So it forms a straight line anyway. So straight angle there, 180 degrees or pi radians. Okay. So now there's also a concept of an acute angle. So let's define what that is. So theta, remember theta, we talked about that notation in the previous video. Theta is acute if 0 degrees is less than theta is less than 90 degrees. So in other words, theta is a positive angle that's smaller than a right angle. So if you want to talk about that in terms of radians, that's 0 is less than theta is less than pi over 2. Okay. So theta is acute if you have this true or this. I mean, they're both going to be true at the same time, but you could be talking about degrees or radians. So if you have degrees, then you think about it like this: 0 degrees, 90 degrees. If you have radians, think about it as 0 and pi over 2. Okay. So theta is acute if it's positive and smaller than a right angle. So let's draw some examples of that. So we could talk about examples in standard position. So let's go ahead and we'll draw one example in the standard position. So x-axis, y-axis. So standard position, because vertex at the origin, initial side is the positive x-axis. So if the terminal side is somewhere over here, then that's going to be an acute angle. Okay, that's an acute angle. Okay, let's draw another example. Okay, so we have this here. Not really, it's not standard position, right? But if we open it up this way, that's counterclockwise, so it's positive. And also we see that pretty clearly it's smaller than 90 degrees, right? So this is, because 90 degrees is a right angle like that, so that's like 90 degrees right there. And we see that this is smaller than that, and it is positive because it opens in the positive direction. So this is another example of an acute angle, okay? So acute angle between 0 degrees and 90 degrees, or between 0 and pi over 2 radians. Okay, so let's draw an example of something that's not acute. So let's say we have that same thing, actually, kind of like that same thing, but what if we open it up this way? Okay, this is too big. Okay, this right here is too big to be acute. Okay, because if we think about it, so if we have the same two rays here, but if we think about opening it up like this, so this is the initial side now, and this is the terminal side. It's opening in the positive direction, but it's too big. It's almost a complete revolution. It's much bigger than 90 degrees. Okay, it's even bigger than 180 degrees because it's 180 degrees would be up here, right? If we stopped over here, but it kept going after that. So this is way too big to be an acute angle, is my point. So acute, acute, not acute because it's too big. Okay, and likewise, we do want to be very careful that if we have another one like this, if it opens up this way, that's going to be a negative angle, and for most people adopt the convention that acute angles should be positive. I think that's kind of like a standard thing there. So this is not acute. So this is also not acute because it's negative, because it opens in the clockwise direction, which means it's a negative angle. Okay, so that's acute angles, and what about obtuse angles? So an obtuse angle, so let's say theta, so remember theta again from the previous video. Theta is obtuse if 90 degrees is less than theta is less than 180 degrees. Or, so that's degrees, but if you want to talk about it in terms of radians, that's going to be pi over 2 is less than theta is less than pi. So theta is obtuse if it's between 90 degrees and 180 degrees. So in other words, it's larger than a right angle, but smaller than a straight angle. Okay? So let's draw a couple examples of that. So let's do one in standard position. X-axis, y-axis. Vertex at the origin, initial side on the positive x-axis, so that's standard position. Now obtuse would be so 90 degrees would be over here, 180 degrees would be over here, so obtuse would be anything in between. Okay. So this is an obtuse angle here. Okay, so again, if we have an angle in standard position, here's the vertex, here's the initial side. If the terminal side were here, that's 90 degrees. If the terminal side were here, that's 180 degrees. So anything in between is going to be obtuse, for example this. Just like up here, here's 90 degrees, so anything over here is going to be acute, right? So obtuse, let's draw another example that's not standard position. So let's actually take this one that we had up here, okay, like this. Or you know what, let's not do that, that's going to be too dangerous, never mind, sorry about that. Let's do another one in standard position. Oh no, let's not. Let's do one like this. Okay, so straight down like this. So let's say if this is the initial side right here, and then this is the terminal side, so if this opens upwards like that. So this is not standard position, right? This is not standard position, but we see that it is between 90 degrees and 180 degrees, right? It's larger than a right angle, and it's smaller than a straight angle. Okay, so a right angle would be like about here. Okay, so this is our initial side because it's opening up this way. So it's opening up in the positive direction, counterclockwise. So a right angle would be over here, a straight angle would be up here, and we do see that this is in between. Okay, so this is an obtuse angle. Okay, so that's two examples of obtuse angles, and we could see one. So let's see one that's not obtuse. Well, let's look at it this way. So let's say we have the same thing, but what if we were to open it up? So let's say this is our initial side, and we open up this way. Well, that's just too big, right? So if we look at it like this, it might be easier to look at it like that. So here's our initial side. If we open up down here, that's larger than a straight angle, right? That's too big. So a straight angle would be over here, 180 degrees. So this is actually larger than 180 degrees. It's still positive, which is good, but it's larger than 180 degrees, so it's too big to be obtuse. Okay, so obtuse is between 90 degrees and 180 degrees. Okay. Okay, two more definitions here. So we'll talk about complementary angles and supplementary angles. So two angles are called complementary. If their measures, okay, so like their degree measure, their radian measure, whatever, if their measures add to 90 degrees or pi over 2 radians. Okay. So two angles are complementary if their measures add to 90 degrees or pi over 2 radians. So that's complementary. So let's see some examples just real quick of complementary angles. So for example, 46 degrees and 44 degrees. Okay, those are complementary angles. Let's zoom out a bit. those are complementary angles because 46 plus 44 is 90. Likewise, 71 degrees and 19 degrees. Okay? Those are complementary angles because if you add them together, if you add up these measurements, you get 90 degrees. What about pi over 6 and pi over 3? Well, so there's no degree symbol, right? So we're talking about radians. So we have to add them together. So pi over 6 plus pi over 3. Well, let's get a common denominator. So we'll multiply this by 2 over 2. So this is pi over 6 plus 2 pi over 6, which is 3 pi over 6. 3 pi over 6 simplifies to pi over 2. And pi over 2 radians, remember that's 90 degrees, right? Pi over 2 radians is 90 degrees. So these two are complementary, because if you add them together, you get pi over 2 radians, which is 90 degrees. And another example, you got to be careful here. Some people require angles to be positive to talk about them being complementary. So in other words, they can only be acute. So you'll have two positive angles that are complementary. But if you don't have that restriction, then you could also say like 96 degrees and -6 degrees. But I think a lot of people do make the restriction that the angles have to be positive, but just want to point out this example in case you don't have that restriction. But it just depends on who you talk to. But anyway, so that's complementary. So what about, there's another related concept called supplementary. So two angles are supplementary if their measures add to, let's erase these also, add to 180 degrees, or pi radians. Let's say, or pi radians. Okay. So some examples of supplementary angles would be 97 degrees and 83 degrees, 12 degrees and 168 degrees. So if you add 97 and 83, you get 180. If you add 12 and 168, you get 180. If you add 3 pi over 8 and 5 pi over 8, what do you get? Well, 3 pi over 8 plus 5 pi over 8 is 8 pi over 8, which simplifies to pi. Okay, so that's pi radians. And likewise, just like with complementary, some people require that angles be positive in order to talk about them being supplementary. Okay, so if you want to talk about angles being supplementary, they're going to have to be positive. But if you don't have that restriction, then you can have negative angles, and you could say, for example, 200 degrees, -20 degrees, just for example. Okay, but just watch out. It depends on who you talk to, so be careful of what your instructor requires. If angles have to be positive, then you can't have this example here. But if your angles don't have to be positive to be supplementary, then this is an okay example here. But also, I just want to point out real quick, some people require that angles be adjacent to be complementary or supplementary. So for example, x-axis, y-axis, if we were to draw like an angle up here, so this angle and this angle, they'll be complementary, but some people require that you have to have something like this, like you have to have them be adjacent. But really, I don't feel like that's a good requirement, because if you want to talk about angles being complementary, if you just take, for example, 46 degrees and 44 degrees, you can have a 46 degree angle over here, 44 degree angle over here. If you add them up, you'll still get 90 degrees, so it doesn't matter where the angles are sitting, it just matters how big they are, so they're still complementary. Okay. Now, it might not be very useful if they're not sitting next to each other, but it really just depends on the application. But anyway, the point is, complementary angles, their measurements add to 90 degrees, supplementary angles, their measurements add to 180 degrees. So that's it for more definitions with angles and degrees and radians and things like that.